AutomationDirect.com presents What is an IP address? Pets have names. Houses have addresses. Banks have routing numbers. 1970s truckers had CB handles. In order to receive communications, everything needs to have some designator that allows messages to be directed its way. In Ethernet-based electronic networks, that designator is an IP address. Every device on the network must have an IP address, and each address in the network has to be unique. An IPv4 IP address is a 32-bit binary number that by convention is broken into 4 8-bit octets. Usually we see this displayed in a decimal format, which gives us the familiar grouping of 4 numbers, each between 0 and 255. There is also IPv6 Ethernet addressing, which uses 128 bits, allowing for a truly staggering number of network configurations. IPv4 is by far the more common scheme for PLC and control networks, and is what we'll concentrate on here. Here's a typical IPv4 IP address for a smaller network: 192.168.1.32. This is the way we humans like to look at it. But let's go back to the way a digital device is going to look at it. These 32 bits hold 2 primary chunks of information that together identify a specific device. The left group of bits is the network ID, and the right is the host ID. It identifies the specific device within the network. The number of bits in each section is the crucial third piece of information here, and we'll come back to that. But for now, let's just say that in our example, the network identification comprises the first 24 bits, leaving the rightmost 8 bits to identify the host. With 8 bits, we can represent any number from 0 to 255, which gives us a subnet address range of 256 unique device addresses. However, in the possible address range of any subnet, 2 addresses are reserved. The lowest address in the range is the network address and cannot be assigned to a host. The highest address in the range is the broadcast address used to send data to all network destinations, and likewise cannot be assigned to a host. This gives us 254 possible addresses in an 8-bit host ID. All the hosts in the network will share the same network ID, 24 bits in our example, but each will have a unique host ID. But what if we need our network to handle more than 254 hosts? We mentioned earlier that there's a third variable, which is the number of bits allocated to each part of the IP address. We may have an IP address in which the network ID is 16 bits, leaving 16 bits for the host ID. Instead of 256 minus the highest and lowest for 254 total possible addresses, now we're looking at 65,536 addresses. But again, the highest and lowest of those can't be assigned to hosts, so 65,534 possible addresses. But all IP addresses look the same to a router or device that is trying to decipher to which network and to which ID it should route a particular message. How does it decide how many bits are intended to be in the network ID and how many in the host ID? This third crucial element of network addressing we mentioned is called a subnet mask. Like the IP address itself, it is a 32-bit binary number, and it acts as a logical AND mask to separate the 2 components of the IP address. Starting from the most significant bit on the far left side of the subnet mask, all the bits that are to be included in the network ID are assigned a 1, and the others a 0. So in our first example with the 8-bit host ID, 192.168.1.32, our subnet mask will look like this. If we logically AND that with the IP address, we get: we've masked out the host ID, leaving just the network ID for the router to start with. So looking at the binary mask, in our familiar group of 4 8-bit numbers in decimal format, we get 255.255.255.0. For smaller networks, this is the most common subnet mask that we'll see. Often, you'll see an address that is notated as the IP address, 192.168.1.32, with the subnet mask labeled separately in the same format. There is also a simpler notation that network-savvy people might use, which is called classless interdomain routing notation or slash notation. It consists of the IP address in the standard format with the number of network ID bits appended to the end after a slash. So the IP address contains all the information that a router needs to deliver data, but the router needs a key to decipher the information, and that is the subnet mask. With these elements, we can successfully route messages to the correct devices. To learn more industry fundamentals, check out our What Is series of videos by clicking here. Click here to subscribe to our YouTube channel.